What's going on, everybody? Today's video, what are we doing and what are we talking about? So yet again, today is an update video. So I figured it's better to share these cool project ideas that I have with you guys rather than just let them sit on a shelf until I actually get to them. I figure it's pretty cool to just talk about them, share the idea, and get your opinion too. Like, I was thinking you guys should throw some comments in there if you guys have cool project ideas or something that you thought might be an awesome thing to try. Definitely hit me up in the comments and say, hey Gerry, I got this cool idea. What do you think about this? I just love it. I love doing different types of interfacing, electronics interfacing, that type of thing that involves some of the retro game consoles. I'm all about that. So again, definitely hit me up if you have cool ideas. So today I've got a couple of things that are pretty cool. One piece of equipment that I want to talk about is called the DCC Adapter Board. What this DCC Adapter Board does is it allows developers that are working on N64 and 64DD development to interface two development cartridges to the N64 and the 64DD cartridge bus simultaneously. So as an example, developers would be working on a 64DD game, and as part of their testing, they would be using an N64 development flash cartridge. Well, the DCC Adapter Board allowed developers to add additional types of memory into the system as part of the test. And so they would have the N64 development flash cartridge in the back socket on the DCC Adapter Board. And then they could add different types of memory cartridges into the system, such as a 256 SRAM pack cartridge. And that would provide the development flash cartridge access to additional SRAM. And that was all incorporated as part of their test. As well, there was a situation for the 64DD specifically where the development systems require access to font and wave data information. And that is provided to the development systems using a special IPL ROM pack cartridge. And so by using the DCC Adapter Board, developers would just simply have to insert these secondary cartridges into the front slot, and then that would allow the overall setup to gain access to that information. And so if developers were using the partner N64 development kits, this IPL ROM pack would get inserted at the top connector that's located on the partner N64 development flash cartridge. At one point, just as more of a proof of concept than anything, I decided it would be kind of cool to show how one of the 64DD development demos, I would actually try to run this without the IPL ROM pack cartridge inserted, and in turn that would show that the fonts could not be accessed. And so when I booted up the system, the font data came back as it was all completely jarbled and it was missing. And the reason for that was because the IPL ROM pack was not connected as part of that test setup. So what I wanted to do was to build this DCC adapter board and repeat this setup, but I would insert the IPL ROM pack on the front slot. And technically, the demo should boot properly and you would see the regular text display on the screen as part of that demo. So that's something cool that I'm planning on trying, and so hopefully if I can rebuild this DCC adapter board and get my own built, it would be a cool test tube demo here for everyone to check out. So yeah, it'd be pretty cool. Okay, so what else are we going to talk about today? Okay, this is another really cool thing. Now I saw some pictures that were apparently taken from an E3 demo back in 96 or 95, I believe. And now this was when Nintendo was demonstrating or revealing the 64DD development system to developers and to everyone that was attending the E3 show. And one thing that was really awesome, now this is just a mock-up here, one thing that fascinated me was how they came out with this. They had an N64 with a 64DD on the bottom, and they had this sort of this cartridge that had an N64 joystick cable. Now this is just a mock-up, but essentially what they had on display was a Game Boy cartridge that had a Nintendo 64 joystick connector on the other end, and there was a cable that had been attached. And they ran this down, and they had a Game Boy connected. So they had it like this, and the Game Boy was tilted like that, and it ran down and plugged into the front socket on the Nintendo 64. And apparently it was the idea to expand the system and allowing the Game Boy to function as a display screen for, you know, different games that they were developing. It was a card trading game, and so they wanted to incorporate the 64DD disk drive and the N64 to communicate over this special interface cable from the joystick to the Game Boy using a custom-made cartridge. And that would allow access to different screens, different menus that were separate from what you were playing and what you were seeing on the television. That, I thought, was the coolest thing ever. A very, very interesting interfacing project. And that just fascinated me. And I thought, wow, what a cool project to do and build something that would allow that type of an interface. And so you would have 3 different types of code you would have to worry about. There would be the code that you would write for the Game Boy specifically, and the ROM for that would allow an interface to function. But then you would also have to write, if you were using an FPGA, which that's sort of where I'd be coming from, I would develop a small FPGA project and a board where I would have a special Game Boy flash cartridge essentially with an FPGA in there that would allow communication over the N64 joystick cable, and that's the Joybus protocol that they call. And so the signals that would be coming from the N64 over this Joybus protocol, you would have to have code written for an FPGA inside your Game Boy cartridge to not only communicate with the Game Boy, but as well communicate with this Joybus protocol signal coming from the N64. So that would be the second. And then the third would be the code that you would have to write as part of the N64 and 64DD game, essentially, to communicate and send the required Joybus signals to and from the Game Boy. And that would be something just so cool to try. I thought, wow, what an awesome project. Very extensive. Not exactly a project for the faint of heart, but wow, how cool would that be? So this is something that I thought, wow, this would be a cool FPGA project. And so now I've dabbled with FPGA work in the past. You guys have seen some of the work I've done. Now this is a D2 board, and I've got a few of these. And I've been doing raw VHDL code for quite a while. And I've done projects where I've written, raw, pure VHDL to drive the LCD display, respond to some switches or push buttons and drive some lights and, work with some of the IOs in that. I've really been wanting to dive into some of the more complex components that are on here and to try and interface with those. As an example, there's SRAM, there's some flash memory, there's an SD card, there's also a USB interface. There's audio, VGA, networking, serial communication, and I've done that before as well. Now, if you guys haven't seen the video that I've done in the past where I actually used this D2 board, and I did a cool interfacing project doing just this. I used the Joybus protocol, and I wrote a program for the N64, and it was driving some code there, and I had a little message that I sent over the Joybus cable through the joystick connector, and I received that signal, the Joybus protocol, directly into one of the IOs on the D2 board. And so I wrote a small program in VHDL to interpret that Joybus protocol signal and then convert that and sort of parse out that little message that I was sending over as part of my N64 program. And I extracted it, and then I sent it to the display. And so I was able to receive that serial message, essentially, over the Joybus protocol, and I had it display on the screen. And I can't remember what the message was, but it was just some code that I'd written and captured that and displayed it on the screen. So that was sort of step one of this idea that I've had for quite a while. Now, actually, just recently, I dove into working with the Altera software a little bit more, the Altera Quartus Prime software. And now for someone that's like a hardware developer, this would just be child's play. This is just sort of common day stuff that you guys are working with. Developers like Marshall, who created the 64 drive, this would just be child's play for them. But I mean, they're hardware developers, right? You know, I was thinking it would just be cool to have some kind of a cool hobby project that would, you know, be a little more basic than that. But I recently discovered it's called the Neos 2 CPU for the Altera FPGAs and like the D2 board and several others that they had released, all these different FPGA models. And essentially what that is the Altera software, the Altera Quartus or Altera Prime software that they have. They have a special part of that software where you go in and you know, set up a bunch of conditions for a CPU that you would want with different, you know, access to different peripherals that are on this board. So like switches or the LCD or the 7-segment displays, the memory, the SRAM, the flash. And what they do is they essentially create all of the VHDL code for you using the sophisticated software package. And it'll create all of that VHDL code that you need for you to program into the FPGA, and then it will respond to C code commands. So it's essentially creating a CPU processor in VHDL, but then you can send commands using standard assembly language or the C code language. And I thought, wow, that's pretty cool. And they have essentially done all of the complex logic that's required in order to access all of the different peripherals that are on these boards. And so it's super powerful. So like if you wanted to get up fast working and having access to all these different, you know, peripherals that are on this board, this software package that's part of the Altera Quartus software, the Altera Prime, is really, really powerful. And so I started to play with that, and I managed just recently to send some C code commands to the FPGA and that Neos 2 processor that was implemented. And I was able to write some information and extract some information from the onboard flash chip. Now that blew my mind, because the pure VHDL or Verilog logic that you would have to write in order to be able to access those devices is quite sophisticated. There's a lot of, you know, different processes that have to be put in place in order to communicate. And, you know, to be able to send a very straightforward command in C code, you know, a very basic function that you would call as an example to print a message to the display, it would be printf, and then a text message. Or if you wanted to write some information to the flash memory, you would have a write command followed by either, you know, an area of memory or a buffer, or you could send some hex information directly into the flash chip and then retrieve that. And wow, very, very powerful. And so that got me excited on this project for, you know, working with the Joybus on the N64 and sending commands at the joystick, you know, elaborating on that project that I did, and, you know, and then creating some, you know, pretty sophisticated, you know, VHDL to interpret that and work with the Game Boy as well. And so I thought, wow, this would be a fun thing to do. And so I think that's another project that I'm going to be working on, time permitting. But again, so cool. Like, just wow, it really, really fascinated me. And I thought this is something, you know, pretty feasible. For those of you that are interested in checking out that project that I did, was where I tapped in to the N64's joystick port, and I did some communication there to and from the N64 and the Altera FPGA. That was a lot of fun. I wrote all that in VHDL and I wrote some code for the N64 console, and I was sending some text messages back and forth and displaying them on the Altera D2 board LCD display. And that was all really cool. It was all pure VHDL. I did everything in VHDL. And so if you're interested in checking that out, definitely give it a watch. It was really, really cool and a fun project. So the link is above, and it's also in the description. So that concludes the video today, guys. I really, really appreciate you guys coming and following my channel and following along with these cool and fun projects. I find it so much fun. I find it so fascinating to work with all this gear and to incorporate my knowledge of electronics and mix it all up in there. Man, it's so much fun, and it's so awesome that you guys are following along and you enjoy the content. So I'm excited to just keep moving forward with this. More projects that I want to talk about, and as well, I am currently working on a couple, and so there will be some awesome in-depth hardware demos coming very soon, and I'm excited at diving into those as well and sharing that with everyone. So that's it. That wraps today's video. Big shout out to all my subscribers and all my supporters. You guys are amazing, and I really, really appreciate all the support you guys have been showing me lately. And yeah, so that's a wrap, and we will see you guys in the next video. Take it easy, and bye for now. Ciao.